Okay, perfect. You will see that I'm the comparison guy. I always like to know what is really special, what is different about organic farming, why is it different, and what can farmers learn from that? Because that's why I always try to compare a little bit, and I hope that you will enjoy it, this way of looking at things. So I'm going to talk about how and to which extent does organic farming protect soils, the crucial role of soil fertility for secure food supply, further potentials for eco-functional intensification, a term which was used by the IFAM EU group in order to bring organic farming issues forward in the EU framework, research framework, and then coming to some of the conclusions. So I'm going to use references, especially from different meta-analysis we did on global soil data from organic and conventional farms. So we investigated a lot into more than 70 long-term comparison trials worldwide. I also use data from well-known comparison trials like the Rodale Institute Farming System Trial in Pennsylvania. This is one example of this more than 70 long-term field experiments which exist at the moment. And you will see that the Rodale data is always on one side, on the very optimistic side. And I will also use data, for instance, from our DOC farming trial in Switzerland, in the northern part of Switzerland, where we compare different farming systems. And this is always on the careful side of the data. And then we also have other experiments in Switzerland, for instance, about organic soil tillage, like is reduced or minimum till, is that possible to be combined with organic farming? Peter Melchett always says, don't promote that because it's too dangerous for organic farmers. But you'll see that we do that in a quite successful way. And we also started a few years ago with long-term farming system comparison in the tropics, because there is almost no data available on organic farming in tropical soils. And this is crucial to have more information about that, because the future of organic also lay in tropical countries and not only in temperate zones. So we have established a few years ago in Bolivia, in Kenya, and in India, long-term comparison trials in a totally different context with totally different crop rotation, but with always the same question: how does organic perform compared to GMO, to conventional farming, and to other subsistence farming systems which are locally represented. So this is the one in Kenya, one of our farms research sites there. So I'm going to show you now some results because it's important as an organic farmer to know where does organic farming really perform better than conventional farming, because otherwise, if we won't perform better, it doesn't make sense that we farm in such a complicated way. So we have to perform better. This is data from this global meta-analysis, and we received from all these 74 long-term field trials all the raw data they produced over many, many years, and we calculated them once again to really to have a scientific overview on the outcome of all the data. And the most important result is, and this was published in the Proceedings of National Academy of Science in the United States, one of the most prestigious scientific journals. So the most important information I can give is that organic fields sequester 450 kilogram more atmospheric carbon per year than conventional ones. And the mean difference in carbon stocks between conventional and organic fields is 3.5 tons carbon C per hectare. So this is average data from all these 74 long-term field trials, and the mean duration of these field trials is 16 years, and it's not a short impact, a short effect. It's really a long-term effect, and we see in many of the very old long-term comparison trial that the sequestration of carbon, if you have different farming systems and if you convert to organic, it is a long-lasting effect. You can count that it lasts at least 20-25 years. In Scandinavian soils, they even saw this sequestration by organic farming lasting for 50 years. Of course, these soils in the north are not so fast digesting organic matter. And you see these differences in conventional and organic farming also in the single experiments. Here is again the Rodale experiment, where you can see the sequestration rates, the two organic systems with manure and legume, and the conventional system. So the conventional system is quite stable, and the sequestration rates are at about 300 kilogram C per hectare and year, and the manure system goes up to almost 1,000 kilogram carbon per hectare and year. For me, this is a little bit this is not representing an average farming system, because they put a lot of organic manure and of organic material into the soil, and this is not representing the daily practice of organic farmers. But nonetheless, you see what is possible as sequestration rates when you farm with manure, with legumes, and so on. A little bit the same situation we have in our Swiss dog trial. You see that the biodynamic system has remained quite stable, although the crop rotation is a very intensive one with a lot of wheat in the rotation, and it is increasing now, and it has increased further in the last years. And you see the very conventional farming system without any manure, only mineral fertilizer, they have lost already 15% of the carbon which was there at the very beginning of the trial. And you can see that both organic with manure and integrated with manure have almost the same values. So it's really the manure, the recycling, which is relevant, and it's not so much whether you believe into an organic or a conventional God. So it has its clear scientific reasons. What was really amazing when we looked into all kinds of soil properties in this very dog trial in Switzerland, that you cannot see the details, but what we can see is that the physical properties of soil, the two organic systems, the biodynamic and the conventional one, were far better than the integrated. The biodynamic and the organic was far better than the integrated systems in physical properties, but also in the microbial properties. some enzymes were double or triple the concentration in soils than in conventional farming systems, but also in soil fauna, earthworms, spiders, carabids, biomass, and so on. It was much better, the organic systems than the conventional one. This was all published in Science in 2002, and when we published it, we were very much attacked by many of the conventional of the GMO people who campaigned for GMO, and we delivered a lot of scientific data to all these peoples, especially from the United States, and finally, for instance, from Mr. Avery Jr., who was at that time very aggressively campaigning against organic in favor of the GMO industry, he came back with the answer. Unfortunately, I couldn't find any fault in your analysis, your conclusions. I have to accept that your conclusions are scientifically sound. For me, that has been so far the biggest compliment I've ever received. You can see, looking for instance at soil microbial biomass, the biodynamic, this is especially for Peter, I always show that, and the bioorganic ones are always better than the conventional ones. And you can see if you have a very good integrated production with a lot of manure, you can come a little bit closer to organic, but you cannot be as good as organic because also the pesticides and you use have an influence on soil biomass and on all the animals living in the soil. What is really fantastic was that we saw differences really down to the diversity of microorganisms and microorganism functions in the soil. For instance, mycorrhiza, which are extremely important because they can tap nutrients for crops, especially phosphorus. And you can see, look here, these are the diversity in the number of different spore types we found in the organic and in the integrated fields of the DOC trial. And you can see this is what we found in the immediate neighborhood in permanent grassland, which is always very rich in different spore types. And this was what we found in maize fields in the neighborhood, which are always a little bit poorer. And you can see that the arable fields of the DOC trial organic are very close to the high diversity of permanent grassland, even though it's plowed, even though it's intensively managed. So the diversity of organic arable land looks equal to high diversity sites on the permanent grassland. And the integrated farming system here of the DOC trial is closer to maize fields in the neighborhood. So this is really a continuous trend we can measure, that we can keep also under arable cropping a high diversity in soil. And this is exactly what Helen mentioned. This is really our wealth we have in organic farming. And some of you might already have seen these pictures several times. And all what we can measure in soil diversity and in soil microbiology can also be seen in soil structure, because soil life is very closely linked to soil structure. And it's extremely important, and you can see here that this is the biodynamic field in the year 24. winter wheat. This was in October or November of the year 24 of the crop rotation. And you can see the difference here between the conventional field and the biodynamic field. It's a huge difference. The soil structure on the surface is completely different. And the result is after a heavy rainfall, the biodynamic soil can really take up the water immediately, can store it, and here you have a superficial storage of water, and the soil structure gets destroyed, and you have a runoff of water into the streets and so on. So it is really a huge difference what soil biology can do with soil structure. And for me, this is the most important advantage of organic farming. We talk about drought resistance, drought resilience, we talk about climate change, and this will position organic farming very high on the agenda if we talk about adaptation to climate change. And all what I showed here, and I could show a lot of results more, because we did a lot of PhD, we performed a lot of PhD studies on this very field trial, because many students are extremely interested and many universities want to cooperate with us for PhD studies. So I could show you hundreds and thousands of more results, but all what we measured in our doc trial can also be shown with a lot of literature. For instance, increased soil organic matter and COR contents in soil was shown by other studies already for a long time. Improved biological properties of organically managed soils is also proved by many literature studies, and the difference between conventional and organic ranges between 40 to 120%. Also, the increased aggregate stability has been published by different authors, and increased water holding capacity, higher water content in soil, and improved infiltration rate of water. So everything is well known, well documented. We really have a strong basis for our claims that organic farming is really one of the solutions for all our soil problems we have. And it's a productive solution. It's not an unproductive solution. So it is an ideal combination between food productivity and soil conservation. And I was very, very amazed that last week, when the Global Soil Week was in Berlin, that everybody was agreeing on that we have a soil problem, but nobody knew the solution for the problems we have created with industrialized agriculture. But in the run of the week, more and more people started to talk about organic farming, and it was really a hot issue at the Global Soil Week in Berlin, that organic farming could offer solutions. So we will see 2015, the year of the International Year of Soils, that we can push this agenda of organic farming. Now, a further question is, can we even do better? And we try to do that by combining reduced tillage systems with organic arable cropping. And you can see this is the research field which is at our institute in Switzerland, in the northern part of Switzerland. It's a heavy soil, and you can see the field, all the different treatments, reduced till and plowed. Everything looks still perfect here after 6-7 years. So we are not under with weeds, so we still perform well. And that's how we perform the different systems. So we have a chisel plow for the reduced system. And we have a moldboard plow for the conventional system, and we also use rototiller. You can see here the different systems. So this is the plowed one, and this is the reduced tillage one. And to be short, if we look at the yields of the reduced tillage system, it started with winter wheat in 2003 with 86% of the yield of the plowed one. It's only conventional, it's only organic, comparing plow versus reduced tillage. The sunflower next year was 105, the spelt 92%. The clover grass 2-year lay was 129, 123, and then the maize following this lay was 135. So the longer the system run, the reduced tillage, the better the yields became. And winter wheat in 2009, 122%. And here, unfortunately, 2020 with sunflower, we harvested only in the reduced till system, and we didn't harvest in the plowed system because we couldn't harvest. It failed completely. And spelt again 93% in 2011. So over more than one crop rotation. It was from 2003 to 2011, the crop average of all crops was 13% in favor of the plowed plots. So obviously it's feasible to harvest more with reduced tillage. Very interesting, the carbon concentration in the upper ground was increased by reduced tillage by 17%. This was on a soil depth between 0 and 10 centimeter, and between 10 and 20 centimeter the difference was 7%. And we already see that thanks to the earthworms, the increase of carbon goes down in the soil profile. So a very important information to give is the abundance and biomass of earthworms measured in gram per square meter. So we can see that over all earthworms, the weight increased in the reduced tillage system by 48%. And the number of animals increased by 67%. Juvenile, young earthworms, 68 in favor of the reduced till system, and the number went up by 80% in favor of the reduced system. And look at the cocon, which are the eggs of the earthworms. So here we have an increase of 438% in the reduced till system. So you can really, so this reduced till system, without using GMO, without using glyphosate, without using nitrogen fertilizer, can be combined with organic, and it is an extremely successful farming system. We have to develop that further, and farmers have to become familiar with that kind of system. Again, here, field emergence for winter wheat, reduced till, very good field emergence, and plough, it is much weaker. Soil microbiological mass was also increased by reduced tillage considerably. It was not increased by whether we used biodynamic preparations or not, because we not only have the difference between plough and reduced tillage, we also have the difference between slurry and compost manures and top fertilization with slurry, and also with and without biodynamic preparation, because many biodynamic farmers tell us that biodynamic preparations are very helpful in converting from ploughing to reduced till, but we didn't see any difference of that. But there is a huge difference between plough and reduced tillage. It's much bigger, the soil biomass here. And only to show that it is not only one side we produce results from, so it's also other sites. This is the experimental sites I already showed. We have another one, and we have 8 commercial farmers who practice this kind of reduced tillage system. And you can see for C. org microbial biomass and dehydrogenase that with reduced till we always have increase with reduced till, so meaning that soil fertility is really heavily profiting from that kind of farming system. And finally, this is about eco-functional intensification, because we have to use soil fertility to increase our yields. We are much criticized of not producing enough to feed the world. And fortunately, there is a lot of data available from different meta-studies, Seufert, Di Ponti, but also from long-term field trials, from case studies done by Jules Briddy in Africa, and also by other meta-analysis from the United States, that the yield of organic is somewhere between 70 or 80% of that of conventional, and this is far higher than those campaigners against organic farming always claim, because they cite figures like 50% yields only. So the worst case we produce might be about 30 to 40% less yields in certain circumstances, but all what we harvest less than conventional farmers is much below the food we waste, 30 to 40%. So we are much better than that. So for me, the solution, the question whether we produce enough or not, cannot be answered in an isolated way without an analysis. And many of the studies from sub-Saharan Africa, where food is really needed, show, and this is thanks to Heinz and Briddy, show that organic farming can double or even triple the yields of subsistent farmers. And this is the most important information, because it can improve yields, it can improve livelihoods in sub-Saharan Africa, and this is a very important information. But nonetheless, we devoted ourselves to produce more in our scientific concepts, and this is all about ecological or eco-functional intensification. So to produce more with the functions of our ecosystems. And the functions of our ecosystems are soil fertility, for instance, are biodiversity, and so on and so on. And I think it's possible to increase the yield, to diminish the yield difference with organic systems via utilizing ecosystem functions. And another question we have to talk about is efficiency and sufficiency. And efficiency, everybody's talking about efficiency, making more out of less. This is the Syngenta and the Monsanto slogan. But we already do that. If you look again at this stock trial since 1977, organic yields over all these long periods of more than 30 years, organic yields are 83% of the conventional ones. And look at the input. The input is for pesticides 4% compared to conventional farming systems. For mineralized nitrogen, 30%. For total nitrogen, only 64%. For phosphorus, 62%. For potassium, 64%. So looking at input and output, organic is already the most efficient farming system. And if you take into consideration also the soil microbial biomass building, and this is in a way also an output. It is an output produced underground. And here the efficiency of organic is 167%. So fantastically efficient organic farming. We don't have to hide away our success stories. We are good, we are efficient, and this is very important. And if you look, for instance, at phosphorus, which is restricted, the chemical industry, they talk about another 300 years for mining. Critical scientists talk about 100 years for mining still left. But if we look at phosphorus, this very efficient use of phosphorus compared to the output, most of this phosphorus is from recycling from livestock. So this is in a way what we called sufficiency. Sometimes English words are very complicated. Sufficiency, meaning that we use limited resources in an efficient way, but we also recycle it. This means sufficiency. With our way of farming, we can keep on farming another 600 or 1,000 years, not only 300 like the industry says. But still we are not there where we want to be. Helen mentioned it. We have to close also the big circles from human wastes and so on. So this will be the next challenges we will face, and this will keep us busy for a long time. Fortunately, because that's one reason that scientists will still be needed in the next decades. Also about yields. No, I won't mention that. basically, we have not yet generated as many scientific results from our tropical soil experiments, but at least I can show you some. This is in Madhya Pradesh state, semi-arid zone, where we compared organic, conventional, and conventional plus GMO BT cotton. We didn't want to be criticized that we didn't use the latest technology. That's why we planted BT cotton in an organic field trial. And you can see here the different, already of 2 crop rotations. The yields for seed cotton, the differences are not as big. The conventional BT cotton system is the best one. For soybean, it's almost no difference. For wheat grains, it's also only a small difference. And for the whole crop rotation, the yields are highest in the conventional and BT cotton system. But if you look at agronomic N efficiency, input, output, because the conventional, the organic yields have been produced with less nitrogen, much less nitrogen than the conventional one. If you look at efficiency, then you can see that seed cotton, the most efficient, nutrient efficient system is the organic one by far. And also for soybean, organic is by far the most efficient one. For wheat grains, organic is even terribly efficient. And over the whole crop rotation, organic remains the most efficient nitrogen-using farming system. And the BT cotton, although everybody thinks that it is the solution, doesn't really contribute to the solution of that problem. So soil fertility building, for me, is the key to higher yields. And we have so many friends in our soils. And at the moment, many scientists work on this plant growth promoting rhizobacteria, which are added to soils and which can increase the access to phosphorus and other nutrient elements. And also many people work on mycorrhiza. Only one picture from Mandori, the Haryana state in India. This is wheat without inoculum, and it is mycorrhiza and PGPR inoculum, a mixture. And you can see here the density of the wheat, thanks to the inoculum, is much bigger than without this inoculum. And you can see on rich soils, the yield increase is 15%. In average of all sites in India, it is 41%. And on poor soils, the increase is 80%. And this is exactly about eco-functional intensification. There is a new consortium working on exactly that approach, using it also for temperate zones. So I think this is really the way forward also for increasing yields. Coming to the conclusions, soil erosion and degradation are the most threatening consequences of modern agriculture, with devastating impacts on food security. Soil fertility building and soil conservation are the most important competencies of organic farming. We can improve. That was shown. We can still improve. And soil fertility building is key to eco-functional intensification and to adaptation to climate change. Thanks a lot for your patience.